Hello everyone, welcome to this iBwave webinar, and our guests today are Seth Roy, VP of Product Management at iBwave, and industry influencer Dean Bubley, founder and director at Disruptive Analysis. This session is going to be recorded, and all the materials will be sent to you after the webinar. So, hi Dean.
Hi there, Anastasia. Thank you. Right, I've got my slides up. I'm going to be talking for about 15 to 20 minutes about my view on the impact of 5G and adjacent technologies on in-building wireless and what that means in terms of convergence, but also use cases and other things to consider. So my background, I'm an industry analyst and futurist. So I cover a variety of different technology areas, from wireless networks to policy and spectrum regulation, also considering areas like Wi-Fi and some communications services. But I tend to look at this through the lens of futurism. So I think about the Internet of Things. I'm looking at AI and machine learning. I'm looking at the sort of potential ways in which we will work in the future, and also act as individuals and society more widely. So some of that is a technology-driven set of changes, and some of it is more human behavior. And so I try to bring these things together, and hopefully in this presentation, I'll talk through some of my views on 5G at a technology level, but also what we can expect in terms of use cases, the types of implications for in-building coverage, but also, and this is the theme that will go through the presentation, talk about what we know and what we don't know. And because we're so early in the 5G era, if you like, there are as many unknowns as there are knowns, and so flexibility and agility will remain pretty critical throughout the next few years. Next slide, please. So in terms of, first off, where are we today for 5G? Now, leaving aside some debates about how exactly we define 5G, which a lot of people get very excited about, the key things to note that we are pretty much at ground zero. Over the last couple of months, a few networks have switched on in a few places, whether that's in North America or elsewhere in the world. The focus this year will be on FWA, which stands for Fixed Wireless Access, and so that's more of an outdoor 5G play, particularly in the residential space, but perhaps for small businesses and some other enterprise locations as well. Towards the middle of the year, we will probably see the first 5G smartphones appear, as well as some mobile Wi-Fi hotspots backhauled with 5G. So I would say that overall, we can expect in 2019 to really still be in a preparatory phase and early examples, which are more about understanding what we can expect in the future. And really the technology is going to be appearing in islands, in certain cities, certain locations within those cities, and not really very much of a focus on indoors for now. The other thing that's worth noting in North America in particular is another technology, which is probably going to be part of 4G, is also going to start appearing, called CBRS. And that stands for Citizens Broadband Radio Service, and is a sort of a more open version of what we see today, and we might get some enterprise networks. Next year is when things start getting more exciting. There will be more phones and more devices. We will still have quite limited coverage in terms of particularly the highest performing forms of 5G, although we might see some lower band switched on in larger areas. Which at least will give the appearance of 5G, if not the full benefits. And again, you have other technology developments that be occurring in parallel. So the latest version of Wi-Fi, called Wi-Fi 6, with capacity improvements and improved performance management, will also expand. 2021, there will be more mainstream devices. We can expect the bulk of mid to high-end smartphones to include some form of 5G. And this term URLLC, ultra reliable low latency communications will start to crop up. This is the sort of what 5G really promises, where you'll get between 1 and 10 millisecond round trip latency potentially for certain applications, and we can expect to have good coverage in outdoor urban areas. Indoors will vary, and here we get into the realms of variables depending on which carriers depend to launch in which spectrum bands. I'll talk about that over the next couple of slides. We'll also start to see the emergence of some private networks, both for 4G and 5G. And this is perhaps going to be relevant in some bits of enterprise, particularly industrial, where enterprises prefer to run their own networks rather than use necessarily a traditional carrier provided version. And that's in a way more like a wide or mid-area version of Wi-Fi from a philosophical point of view. Beyond 2022, things obviously, there's more unknowns and more variables that come into play. But we should certainly expect for both consumers and business users the smartphones to be 5G dominant from around that period. And we're going to start to see some other more mainstream use of some of the associated techniques around 5G, such as edge computing and what's called network slicing, which is more of a control way to virtualize capabilities onto one network. But I should stress as well that, again, we're not quite sure what's going to happen with spectrum. We're not quite sure who's going to be deploying what and where, but there will be a lot of 5G and an increasing range of innovative use cases, both indoors and outdoors. Next slide, please. So a quick look at the technology, and I don't have time to go through all of this on this presentation. The key thing to know from a spectrum point of view, 5G, is that there are going to be low, mid, and high band frequencies that are used for 5G. A lot of the discussion is mostly around the high band and certainly the millimeter wave, because that's new. And you'll see a lot of discussion around 28, 39, or even more gigahertz bands used, again, perhaps for fixed wireless access initially, but then also for mobility as well. From an in-building point of view, I'm expecting a lot of the action on 5G to be in the mid-band, which is where we see the highest capacity versions of 4G today. But there will be some new bands that emerge as well. Depending on which country we're in, you may well see between 3.4 and 3.8, or even the sort of 4 or 5 gigahertz bands as well. And that's going to be an interesting sort of mix of national licenses, local licenses, unlicensed variants, which are a bit more reminiscent of Wi-Fi today, and also new models around spectrum sharing. That's really interesting. Again, the US, the CBRS band fits into that category, initially for 4G, but 5G as well, where there will be more local licensed operators, which could be traditional carriers, they could be regional carriers, or they could be private enterprises or third parties, cable companies perhaps, what are called neutral hosts, deploying network indoors. And this is where some of the challenges start to come in for existing in-building infrastructure. A lot of the existing in-building systems, particularly distributed antennas, really only work up to about the 2.6 gigahertz level. And although some of the newer solutions at higher bands, we'll also start to see a lot more requirement for new or upgraded implementations, both in terms of the radio source, which might be small cells, might be remote radio heads, but also the fiber and power infrastructure to support that. On the low band, we can start to expect to see some of the existing lower sub-gigahertz or sub-2 gigahertz bands used for 2G, 3G, 4G being refarmed by some of the carriers for variants of 5G. And they should have better indoor penetration from outside, but they won't be able to support, in most cases, the sort of ultra-reliable low latency services I mentioned before. And then in parallel with the radio networks, there's a lot of other technology that's going into the back end of both 5G but also 4G and other technologies. Some of this is going in the core of the network, some of it is in the radio. I can't go through all of this, but there's a lot of really interesting work that's being done around automation and AI in the radio network for planning and optimization. There's a lot of interest in this term MIMO, particularly in the higher frequency bands. MIMO stands for multiple in, multiple out, which is where you have several antennas simultaneously working together to help to target capacity to or from devices. And although that's existing in 4G, in 5G, it's going to become a lot higher level of number of antennas and ability to pinpoint capacity for particular users. The other thing I'll draw attention to now is towards the bottom of that panel is the CRAN and ORAN, and that's Cloud RAN and Open RAN. We're starting to see various models emerge for disaggregation of the radio, both at the macro level outdoors, but also that extension into the in-building, which is where you may well see more splits between the electronics of the radio and the actual antenna linked together via fiber. There are various standards emerging for that, but that will have an interesting set of effects depending on the type of building we're in. Next slide, please. So to sort of put this into context, 5G is not just one new radio. It's not like a 5G. There are multiple different variants on this technology, which are going to emerge at different times and for different roles in different places. We saw a bit of that with 4G, next build please, where you already have certain subcategories of 4G. We've seen unlicensed 4G, private networks, narrowband versions of 4G for Internet of Things, and so on. But this type of fragmentation is going to occur even more so in 5G. Next build. So I already mentioned the fixed wireless versions and private, but we're going to see a whole host of other innovations around 5G, whether that's ultra-low latency versions of it. There's this term MMTC, which is sort of massive machine-type communications, which is a sort of very dense IoT intended for, could be in building sensors, could be smart cities and anything else. TSN is time-sensitive networking, which becomes important in some industrial capabilities where you need to have very, very tightly controlled latency and jitter for, say, production machinery. And you also have a link between the radio and the core network. So NC stands for new core, and then MEC is the multi-access edge computing. And there is an expectation that distributed compute will go hand in hand with the radio infrastructure, particularly for certain applications where latency is super critical, because it's not just the time the latency for the radio part of the network. It will become ever more important to have the compute and cloud capabilities closer to the edge as well. Next slide, please. So to drill into the use cases a little bit more, and obviously this is going to vary by industry, but some of the sort of headline things we can expect over the next few years. We hear a lot of talk about AR and VR, augmented and virtual reality. At the moment, most of these devices use Wi-Fi rather than cellular, and I expect that's probably going to continue, but we will see some that are cellular connected. Whether they're used indoors or whether they're more for field workers is yet to be seen, but these tend to have very low latency requirements as well as high data throughput requirements, not least because the physiological effects of headsets mean that you can feel nauseous unless you have very, very responsive movements of the image to, for example, the way you move your head. There will be a lot of cloud and essentially everything as a service capabilities delivered, often with low latency requirements to whether that's to phones, to desktops, to laptops, and other devices. And I think that responsiveness of cloud applications is probably it's a bit less glamorous than some of the 5G use cases, but I think that for enterprise that may be one of the more important. Automation and robotics, whether that's in a warehouse or a factory, or even if it's just in a normal carpeted enterprise office for perhaps a security robot or other automation devices around ventilation and air conditioning. In some cases, they will also have high throughput requirements, for example, for video inspections of particular facilities. And also there are potentially safety issues here if you have moving machines and humans in the same space, where again, you need to have the reliability and the responsiveness. There's a lot of discussion around machine vision, which links in with this, but that could be for production, but it could also be an extension of unified communications, where you might be having video conferencing, which has edge processing to allow more optimal interaction between humans, as well as also the machine level of intelligence to perhaps look at emotional analysis or a variety of other use cases. There's a lot of really interesting and exciting work that's going on there. In locations like hospitals, there is a lot of discussion about whether we will see wireless connections for life-critical systems. I have to say I'm a little bit skeptical about some of the remote surgical use cases that people talk about, not least because surgery is often three walls from the outside of the building, and often you have metal lining in case of RF interference. But I think we will see, for example, mobile machines in hospitals on trolleys that perhaps cannot necessarily use Wi-Fi for various reasons, and so connectivity via cellular is certainly a possibility, and they may well get wheeled from patient to patient. Multi-carrier is important. Although a lot of in-building systems are single carrier at the moment, you need to think that in the future, you may well have people on site with different networks, and not just their phones, but also you could imagine an engineer on site coming on with a piece of diagnostic equipment with an inbuilt eSIM, embedded SIM, from a carrier that they may not even know which carrier is in it. You will also find that some more advanced devices support multiple connection paths, but either bond them together or use them for redundancy and backup and failover. So I think we need to think more about how we support as many different carrier networks and therefore frequency bands as we can. Voids and stairwells. Because 5G will be connecting things as well as people, the locations for coverage are going to be essentially the whole of the building on a three-dimensional basis, including perhaps locations in the ceiling voids, or, stairwells, fire escapes that perhaps are less well covered today. And a similar issue is going to be around the materials that get used for different structures. And so it could be that we have CCTV cameras or other production monitoring systems on the outside walls of buildings. You may have metalwork in factories, which has unpredictable radio effects. But we start needing to be thinking a lot more closely about the physical environment and how that may change as we have more automation over the next 3, 5, 10 years. What we have today will not be static because of other technology evolution paths. Next slide. So this slide, I'll leave people to download and look at their leisure, but essentially, for any given industry or vertical sector, there will be different profiles for what 5G brings, whether it's more about employees or visitors with smartphones, whether it's about new use cases and devices with these low latency requirements and high quality requirements. And quality here is both throughput, but also its coverage everywhere in the building. If you think about it in terms of the availability for a robot, it's not just in terms of time, it's in terms of space as well, and it may well go to places that humans don't go. There is this term massive IoT, which is more if you're looking for deploying wireless sensors and other automation equipment, perhaps not so ultra latency critical, but you may well find that you have hundreds or thousands of such devices that may need to connect in tandem. And the last one is where there's an opportunity for private cellular and what's called neutral host. And neutral host is sort of a location-specific wholesale network where you may well find the building owner or the landlord or a third party like a tower company owns its own spectrum and owns its own network and allows others to roam onto it. And that's something that is a really hot area in certain locations. For example, people are looking at that for private networks for manufacturing plants, or perhaps in large new property developments as well, and maybe airports and so on. For each of these industries, you can sort of double click down. There's sort of, even within retail, there's so many different sorts of subcategories, and you can certainly imagine that for each of these there will be pockets of each of those type of applications depending on a given company. It could be, I don't know, virtual reality headsets for clothing fitting, or for tracking people around a retail store, or in education. Clearly there's going to be a lot of innovators that will start to take advantage of the networks once they're there indoors. Next slide, please. I've mentioned a couple of times this idea of enterprise networks, and I think that one of the things we're going to see is a lot of different models for delivering wireless capabilities in businesses, and particularly indoors, but also across the wide area as well. And we're still at the earliest stages here. There certainly are some locations that do today have private cellular networks. You find mining companies or oil companies that run their own localized networks if there's no coverage from the national networks. There could be an offshore wind farm, for example. But I'm expecting to see this become a lot more sophisticated over the next few years, and emerging from, if you like, historically the main private wireless networks that companies have run have been Wi-Fi oriented, or perhaps a couple of proprietary industrial wireless technologies. But we're going to start to see enterprises either want to become their own virtual provider on one or more host carrier networks. And again, with 5G, I reference this term network slicing. That allows the carriers to divide up their network on a virtualized basis and potentially offer what's called slice as a service, or perhaps a custom slice of the network managed by the carrier on behalf of, it could be one particular company, it could be an industry, so you can imagine automotive or retail or finance. And over time, I would expect the tools to enable this to be deployed and managed to become much more sophisticated. In theory, these slices could offer guaranteed or security or latency or other characteristics which are partitioned for that particular location or that particular customer. That is going to put some interesting requirements on the in-building infrastructure as to whether it can support that all the way down to the radio, and obviously is going to need to have both the capacity and the coverage, but also in some cases the active equipment that's able to support that truly on an end-to-end basis. And I also expect we're going to see, let's say, various other new classes of service provider, either organizations running their own network or contracting with perhaps a specialist indoor neutral host provider, going from today's simple coverage to a much more active role in future. And next slide, please. So to wrap up, my main view on this is there's a lot of potential around 5G. There's some really exciting possibilities. The timelines are challenging. We're seeing early deployments, frankly, earlier than many expected. And there's some stuff that we know about 5G in their building. There will be more types of devices. Now, this is happening irrespective of 5G. If you look at the Internet of Things world, whether it's on 4G or Wi-Fi or Bluetooth, there's an increasing variety of Internet of Things products. You only have to look at the announcements of things like flexible screens at the recent Mobile World Congress to think, well, in future we're going to have bendable panels, LCDs everywhere, and compute everywhere as well. And with that, both in terms of the display and the compute capabilities, you'll need more throughput, more essentially gigabit speeds will become more prevalent. But at the same time, we know that we'll have multiple radio bands, both in terms of frequencies, low, mid, high, but also a mix of frequency and time division duplexing, as well as various forms of multiple antenna usage with MIMO. At the same time as 5G, we'll still have certainly 3G and 4G, and maybe still some old 2G in locations as well. Wi-Fi is not going away, and indeed is becoming more sophisticated and more important with the new Wi-Fi 6 standard, as well as other radio technologies like Bluetooth and Sigfox and LoRa as well. There will be requirements for both single and multi-carrier indoors, and I think that's something to bear in mind. And overall, there will be requirements for lower latency. We start needing to think about what does latency mean for an indoor location, and how do we measure it, how do we monitor it, especially if we have these ultra-reliable requirements for medical equipment or production machinery. We need to actually demonstrate that that latency is manageable. There will be more types of stakeholder involved, and there will also be more customization and more localization for particular applications and particular industries. Now, that's what we know. There's a bunch of other things that we don't know. Next slide, Bill, please. So we don't yet really know how millimeter wave is going to actually the radio and the device, and that has huge challenges, both in terms of the enclosures for antennas, but also the sight lines in buildings, which obviously can change as people move internal walls or other bits of furniture, or even people themselves. As yet, we're not quite sure how well that's going to work indoors in reality. Next, please. And so that ties in with this issue of how do we define and measure and monitor in-building quality of service? What does quality of service mean, and from whose perspective? I think that's something that's going to be a challenge, but we'll certainly need to optimize and manage that as best we can. Next, please. The 5G private aspects and neutral host aspects of 5G sound very interesting, but we're not there yet. At the moment, a lot of ideas sound very good, but there's a lot of complexity before companies can roll out their own networks. And it may be that they get so far, trial a few, and unless they're very expert, rely on the carriers after all. But we won't know that for another year or two. I mentioned Cloud RAN earlier, and that's going to be another interesting area, essentially the virtualization of the radio network, whether that's just in-building or whether we tie together in-building and macro, so sort of with fixed connections to a data center with radio head ends rather than having a radio source in each building. That is something of an unknown. We don't have any large-scale deployments thus far, but we certainly expect that to occur on the same time horizon as the rest of 5G. But again, it has lots of variables, and there's multiple different ways in which that can be deployed, and where you put which bits of electronics and which cloud resources. The spectrum licensing environment is very fluid, both within any country, but also internationally as well. And I'm certainly following at least 6 or 7 different approaches around the world towards new sharing bands, which might look like the US CBRS, which might look like localized fixed licensing, and even some people talking about much more dynamic real-time approaches to spectrum licensing over the next 5 to 10 years. We're not quite sure what the bands are going to look like. There may be new wholesale models. The US is looking to go beyond CBRS to the next band up in C-band, where you have not just the local licensing, but you have to think about incumbents in those bands that you may need to work around for certain locations as well. Convergence of the fixed and mobile infrastructure, that's a huge topic, and exactly how you define fixed infrastructure is going to depend on the type of enterprise. But certainly within buildings, there will be a lot of requirement for local connectivity, for connecting up small cells, for connecting up Wi-Fi access points. There will still be devices that have fixed LAN connections, particularly in, say, manufacturing environments, but also you can imagine hospital equipment, servers, and you won't necessarily rely on wireless for every screen in, say, a contact center either. So I think we're going to see people considering how they lay out their buildings, and also, given the likely changes in the way that we work over the next 10 years, having the ability to reconfigure buildings to demands of society and industry will be very important. So I think people will start to look more holistically at the connectivity infrastructure within their sites. Next point. We don't yet know where the edge is going to be. There's a lot of excitement about edge computing. I've come up with I've seen at least 10 different definitions of how you define edge, and also whose edge is it? Who's going to be the cloud provider? Is it going to be the Amazons and Googles? Is it going to be the carriers? Is it going to be built into the end user environment, a sort of wiring closet 2.0? Are we going to have a shipping container full of servers in the parking lot? We don't know, is the answer. There's a lot of hypotheses here, but we will need to bear in mind that it's not just end users that we have to connect, but also new classes of compute resource. Finally, there's a couple of wildcards here, and certainly I know the US government and also Mexico and South Africa and others have started talking about wholesale networks, and whether that's a marketplace for radio capacity at a spectrum level, whether it's more of a single network that's built and then you buy capacity and services, we don't know what's going to happen over the next few years. And there's certainly been more discussion of that I've seen over the last 6 months than I have in the previous 10 years. So we need to start thinking about designing our buildings in the expectation that there will be new wholesale models, as well as private networks and obviously the traditional carrier model as well. So the final point I would make before I wrap up is that one universal, in my view, across this is that there will need to be more fibre, both within buildings and across the wide area for backhaul, for front haul, for antennas, for the fixed connections and for the wireless, for 5G, for 4G, for Wi-Fi. All of these will need more connectivity within each location. And then as much manageability and flexibility of that as well. And that will be important both for the capacity to radios, but also the ability to implement mechanisms to do network slicing and management of quality of service over the future as well. Thank you very much, and that concludes my part of this presentation. If you want to follow me on social media, I'm Disruptive Dean on Twitter. You've got my email address, and I'm also on LinkedIn as well. Thank you.
Thank you, Dean. Very thorough and good presentation. We really appreciate your insights. Today, what we're going to be talking to you about is our product strategy when it comes to 5G. This is known as DNA, which is Dense Network Architecture. We're going to walk you through a use case of Converged Enterprise Building Network, and we're going to show you some key benefits of digitization along with efficiency gains and 5G. At the end, what we want to show to you is how having a unified approach to in-building will give you much more optimization of the 5G deployment. So let's start with our product strategy, which comes down to DNA. A few years ago, when we were thinking about how to evolve our product when it comes to 5G, 5G was mainly just noise in industry. But when we started to evaluate what 5G actually is, we realized we needed to expand our approach instead of just designing for 5G itself. This really brought us into the fiber deployment because, as Dean pointed out earlier, 5G is very data intensive. And as a carrier or operator is investing in 5G, they want to use fiber because it's future-proof and you can build different technologies on it. You have, of course, 5G, but you also have Wi-Fi 6, which also has a very data-hungry approach to delivering technology. And finally, you have network virtualizations. With 5G, one of the promises from the technology is that it's going to enable you to deliver bits cheaper. The only way you can do that is through virtualizing pieces of your network. You'll see this within CRAN, which can be termed Cloud RAN or Central RAN, depending on who you're talking to. And then there are new technologies such as XRAN coming out to market, which again simplifies how that network will be delivered to the user at the edge. So let's take a look at how this looks on the life cycle. So you see from pre-survey, survey and design, final design, approval, installation, maintenance, our tool enables you efficiencies through all of those processes into mixed-use developments where you can really design a converged system. When you look at broadband connectivity, really what you're trying to do is to optimize the fiber that you have in a region, connect as many buildings as possible, and with our tool, we allow you to do that. Of course, you're probably going to want to add some cellular connectivity. So as you know, we started in this industry over 11 years ago, and this is really what we started designing for operators to design and deploy and to eventually make more efficient their own networks. So here you can see a wireframe of an in-building network. This can now be an MDU for deploying fiber. And essentially what you can do once you have the system in iBwave is you can deploy whatever technology meets your needs. So in this case, you'll see that there's fiber deployed throughout the building. But then you can come back later, and as your business case opens up to new technologies, you can layer those on to the iBwave file. So that tells you you're prepared for not only the technologies that exist today, but if you use our tool, you're also prepared for the technologies that will exist tomorrow, such as IoT, as Dean pointed out earlier. So now let's look at how that translates into our technology stack. So when you're looking at our technology stack, we're here to help you through your end-to-end lifecycle of deploying an in-building wireless system. We do that through the use of Unity, which also can be called the Central In-Building Design Hub. So this is the central repository that holds all of the activities around your in-building network activity. Now, we've built certain pillars of technology that can help you through multiple use cases or verticals, which would be wireless, wireline, or enterprise. And we built the technology in a way that we can easily add a new one and plug that in as the market continues to evolve. But we know this industry is very complex, and there are many people that work with you or an operator to actually deploy a system. So really, when we design our solution, we design it to understand the persona that's currently acting on the system at a time. So that means that not only could your enterprise sales rep access the information, but also the network technician. So we're really trying to not only manage the end-to-end lifecycle, but we're also trying to help you manage all the vested interests in that lifecycle. We also interface with third-party network tools, and we also interface with the operator's network or the network that the Unity platform exists in. So it's very, it has APIs and is able to quickly integrate within those spaces. So now, if you think about all of your designs and now you have them all digitized, you can better plan your rollout for 5G. So as you're contemplating where do I put 5G, how much is it going to cost me, what's the design going to look like in the future, you can quickly access that information using Unity as your new data store for all the designs that you currently have in field. But it goes past just 5G because now you can also think about other use cases that 5G is enabling. So an example would be IoT. It would be going into the private LTE space for networks. It could be any of these machines that you're putting into your installation. And you would be able to use Unity to help you evaluate what the impact's going to be to your network. So Unity really is that central store for you to enact anything that you need to within your in-building design. We have many other products that build on Unity. An example of that would be our mobile note or planner, which again, you can quickly check something out and go in that space and look at the designs. Now let's look at what this would look like in an MDU space. So now you have Unity, you have a design that currently exists. Let's look at what it would look like in traditional. In traditional, what we're seeing even today, surprisingly, it's still pen and paper. The designs are scattered, they're not centralized. So if you're looking at the traditional process of a user that doesn't have a solution like ours, you would have 3 different teams all doing 3 different activities. But with iBwave, we like to optimize, and what we've done is because you have that data already on Unity, you're able to use that file as many times as possible to continually build value of new technology that's being deployed. So here you still have one visit, you already have the design. You can quickly layer on new technology. You can communicate with the SI or the integrators that are helping you do the deployment. And you can really harmonize that process across your broad industry that might be siloed today. So now you're also gaining efficiencies of scale as you're broadening what technologies you're deploying within your networks. If we look at this from a balance sheet point of view, You can see up top you have the traditional process, so you have backhaul, wireless, wireline, and then you're having to rework those processes to fit new technologies. Again, with iBwave, we're trying to consolidate that for you to help you optimize the fit-to-finish process. So you do one survey, one design, and you can have essentially one file that would have all technologies within that file. Again, what this does on top of the benefits that you're seeing here from a time and cost perspective, but there's other things such as communication and collaboration that you don't necessarily put on this sheet, but we're also helping to make that communication much more simplified. Again, the designs are considered by all teams. A new party can come in tomorrow and say, hey, I have a great ROI for a technology we're deploying. They can already use your assets and go ahead and see what that would look like in terms of cost in your network. So you're really freeing up a lot of technology deployments in the future. 5G and augmented reality seem to go hand in hand. You're seeing a lot of companies invest heavily in 5G, and it's really because it's bringing that digital world to life. And really, when it comes to in-building deployments, a lot of the challenge actually becomes, how do I get the building owner to sign off on this technology that I'm putting into their space? And do they think I'm putting it in the right space? Is it aesthetically pleasing? All these questions can be addressed through augmented reality. So you're able to do site survey with position tracking. You're able to place equipment as needed. You can even predict, have that prediction visualization as you're walking through the space. So there's a lot of definite benefits from AR. The nice part about 5G and AR is it will also make use of the mobile edge computing, again, that Dean referenced earlier, because a lot of these devices will need to use that distributed processing in order to really benefit from AR, and it's a perfect marriage of technology that's currently being implemented in field. So at the end, what we're trying to do is simplify all of our lives and really take advantage of all the technology that's certainly being released in 2019 and the future. And really through our product, we're trying to make all of this real through an actual deployment. So being able to do a design, once you have that design, you use that file over and over and over again, deploying new technologies as they come up. We will give you the tools to be able to do that. And through Unity, you can share those designs with all of your partners, making those deployments a reality. So we talked earlier about the complexity of how 5G is changing the marketplace for networks. Really through iBwave, we're trying to simplify that process so you can think about deploying technology and not have to worry about how am I going to interface or how am I going to create a design. We can do that with you with our product. Thank you very much.
And we have some questions here. First one is, what frequency bands will be needed for 5G?
That's a good question, and is going to depend where you are in the world, and you also it's going to depend on whether the carriers decide to keep some for indoor only, or sorry, outdoor only, and also whether they reform their existing bands. The pioneer bands, if you like, the ones where there's the most interest at the moment globally, I'd say in the mid band there is between 3.4 and 3.8 in a lot of the world, and then the millimeter wave at depending where you are, 24, 26, 28, 39 gigahertz. But then beyond that, I'm expecting in the US, you will find from probably outdoor to indoor rather than indoor only. T-Mobile has 600 megahertz. There's speculation that AT&T is probably going to refarm its 850 megahertz. Sprint's been talking about reusing its 2.5 gigahertz band. I think China is doing 4.9. There's so many different ones, and one thing to watch out for is that some of those are FDD and some of those are TDD. The other thing that there's a couple of vendors that are now looking at whether we can partially refarm existing 3G and 4G spectrum bands. So that I know at least one vendor had a solution in Mobile World Congress where they could essentially split a given band between 4G and 5G. And that's something that we may well see emerging more of over the next couple of years. So sorry to be vague on that, but it's there's a world of possibilities, and it's a bit too early to work out exactly what's going to be used for which application.
Thank you, Dean. The next question is, who's going to pay for indoor 5G coverage?
Well, my view on that is, again, it's going to depend on the industry. And whether the profile of a given location is, if you like, the general public who are visiting somewhere like a shopping mall or a stadium, whether it's residential where perhaps property developers can get higher prices for good infrastructure for wireless, if it's an industrial location which perhaps wants to have its own network. So one of the challenges for the carriers here is this idea that if getting someone else to pay for a carrier public service is going to be an interesting challenge, given it will become easier for them to deploy their own or work with a neutral host provider. And there's an argument that's saying that if you're going to spend that money on in-building coverage, do you want someone else to be using it to be driving revenue rather than yourself? But there's going to be a shift in dynamics. But to be honest, it's going to come down to negotiation and demand and supply in a given location, how much competition there is, and the profile of demand for a particular user base, as well as how good the existing 4G and also Wi-Fi is as well. So no simple answers, unfortunately.
I agree, and I think as you start talking about these private LTE networks, I think there's some opportunity to offload some of the cost back into the enterprise. CBRS is also another great example of a technology that might give more opportunity to an enterprise to spend. However, I would agree that for the most part, it's still going to be built on a business case, and we'll probably see neutral hosts and operators paying for a lot of the in-building.
Yeah, it may also depend whether it's new build or not. And if it's new build, then you could imagine that they may well have high-end infrastructure built into the upfront capital costs of the facility, and not just for communications, but you might find that there's smart lighting and other environmental services in the building as well, just as part of the overall creation of a so-called smart building.
All right, the next question is, how can existing systems be upgraded, or do we need to REAP or replace it entirely?
I think, do you mind if I, just
Yes.
from a design perspective, it's going to depend on what network was designed in. Going from 3G, 4G, if you have a hybrid fiber coax system, most of the time, from what we're seeing, there will be a new layer or a rip and replace. Again, it all depends on what your KPIs you've designed for and what you're looking to achieve. So if you're trying to just do a simple implementation of 5G NR, you're going to have different requirements than trying to go into millimeter wave or something when you're trying to do network slicing, as Dean pointed out.
Yeah, no, I think it's going to depend on the type of location, and you can imagine that for a residential building or a carpeted office, then there's going to be very different requirements to a hospital or a sports stadium or even a hotel, for example, or a convention centre. And I'd say as well that it's not just going to be the 5G, it's going to be Wi-Fi 6 and other technologies as well. It may well be that for some locations the business case for complete refurbishment of the internal wiring, there's multiple different contributing lines.
Another question was about 5G NR and beamforming.
Okay.
Good question. I mean,
It just says 5G NR and beamforming.
Right. Well, so obviously beamforming is an inherent part of some of the work that's being done on the MIMO multiple antenna technology, and certainly in the outdoor world, beamforming is going to be very important. For example, with people or vehicles moving along streets. In building, it may be, and Seth, I'm interested in your take on this. It might be quite difficult to model because you'll have a lot more reflections off different surfaces and transmission through walls and so on. Millimeter wave is going to have to perhaps be used some forms of technique, although I'm really not quite sure how that's going to work in reality, given the number of obstacles within buildings. Seth, do you have any views on that?
Really, when we're looking at beamforming, the use cases that we're primarily focused on are stadiums and larger venues. I agree, and even in an office space, beamforming is very difficult to do any sort of simulation on because of the walls. More than likely, even in a conference room, you'd need 2 radios to support such technology. So we're still looking at how the carrier is looking at deploying and what venues they're focused on. But right now, we're only looking at the larger venues, such as a stadium, for beamforming itself.
The interesting thing I'd add to that is that if you look at what's going on in the Wi-Fi world at the moment, beamforming is considerably more advanced, and that's because of an additional intelligence layer. Certainly some of the work I've seen on both enterprise but also residential Wi-Fi, they have an additional layer of whether it's cloud-based or on the device that actually tries to work out what people are doing. And so you can imagine in a residential setting, the Wi-Fi, particularly if it's a mesh Wi-Fi, may try to work out that you've got a 4K TV upstairs in the front bedroom, you've got a Roomba or a automated vacuum cleaner or lawnmower that moves around. There's people that come down the stairs holding a tablet. And it tries to, the systems I've seen are starting to try to understand the use cases. Obviously, there's some privacy and confidentiality issues there, but really you end up with that type of contextual awareness in the wireless system where it knows that it's in a conference room and that people tend to sit around the table and there's a screen at one end. I think there's some people who are going to make a lot of money out of the AI smarts that go behind that, though.
The last question is about millimeter wave added in the next version, I guess. What millimeter wave is going to be added in the next version?
So we're adding a few bands for millimeter wave. We have an alpha currently that exists today for 5G. And as we're working with the operators, we're enabling specific millimeter wave to support both the CANIS region and the APAC region. So that will be released mid-year in 2019.
That's it for questions. Thank you, everyone.
Thank you.
Thank you.